For section 8.4, we're going to look at adding and subtracting radicals. Your essential question is how to add and subtract radicals. So when adding and subtracting radicals, only radicals with the same index and radicand can be combined. So I want to emphasize that they have to have the same index and they have to have the same radicand. Now when we were talking about multiplying and dividing earlier, we can go ahead and multiply and divide with different indexes and different radicands, and that's okay. But adding and subtracting we can't. So it's really important that you recognize that they have to be the same index and same radicand to be combined. For our first example, I want to look at a pretty simple one. Remember, we got to check that we can actually subtract these two. So I've got 2 cube root 3 minus 5 cube root 3. So the first thing we need to check is that we have the same index. So this has an index of 3, and this also has an index of 3. So since they both have an index of 3, it's the same index. We're good there. Now let's check our radicand. This has a radicand of 3, and this also has a radicand of 3. We have the same radicand. So once you've noted that you've got the same index and the same radicand, it's okay for you to go ahead and actually just subtract the outside numbers. So in this case, 2 minus 5 is negative 3, and then you just carry down that cube root 3, making negative 3 cube root 3 your final answer. Now let's look at a little bit more complicated problem. I'm looking at this problem 2 root 20x minus root 45x, and I'm noting that I actually have the same radicand right off the bat. I've got square root and a square root. What I don't have is the same radicand. So what I need to do is I actually am going to try to reduce these and see if I can make them the same. So I'm going to start by taking that 20x out here to the side and reducing it. Now you can reduce radicals using perfect squares or using primes. So I'm going to use primes and look for pairs. So it looks like I've got a group of 2, pulling this 2 out. So this 2 is going to come out with the original 2 that's already out there, making it a 4. This 5 and this x are going to have to stay in. So it looks like I've got 4 root 5x. Now I got to look at this 45x and try to reduce that. Looks like it's divisible by 3, 15, 3, 5, and a 5. Got a pair of 3's. The 3 is going to come out, there's nothing for it to go with, and that 5 and that x are going to go back in. Now all I've done is simplify this problem. I haven't changed anything, I've just simplified it, and what happened was I ended up getting 2 of the same radicands. So I can actually put these together, and the way that we do it, remember, is we just go ahead and subtract the numbers on the outside. So 4 minus 3 is 1, and then you carry down that root 5x, and you're finished. That's your answer. All right, let's take a look at this problem. So now what we're going to do is we're going to mix kind of all the rules, really. So what we've got is 2 times root 75/16 plus 4 times root 8 divided by root 32. So when you're given a huge, massive, complicated problem like this, it's best just to take it piece by piece. So I am first just going to simplify this left-hand side as much as I can before I even try to put it together with that right-hand rational. So the first thing I notice is I don't know what 75 divided by 16 is, but I am going to try to split up that root and see what I can do. And it looks like I can do a couple things here. So first of all, that 2 technically belongs in the top since it's technically 2 over 1. So I'm going to pop it into the top with the root 75. I'm also going to reduce the root 75. And the root 75 combined with the 2 is going to reduce to a 10 root 3. And the square root of 16 on the bottom is just going to be a 4. So let me show you where that 10 root 3 came from. If I actually reduce 75, let's see. It reduces to 5 root 3, and if you pull that 5 and that 2 out, that's where the 10 came from. So that's 10 root 3 over 4. At this point, I really can't simplify this any further other than possibly to take 10 root 4 and divide it out and simplify that. But I think I'm going to jump at this point over here to the second guy and see what I can do over here to simplify it. So the root is already switched up, so at this point I'm just going to try to reduce my 8 and try to reduce my 32. Well, the square root of 8 actually reduces to 2 root 2, and since the square root of 8 reduces to 2 root 2, when I combine it with that 4, it becomes 8 root 2 on the top. The square root of 32 on the bottom actually reduces to 4 root 2 if you simplify it the same way I did over here. And what that does is it enables those root 2's to completely cancel, just leaving me 8 over 4. Now, I've simplified that pretty far. I could divide it out to 2 over 1 if I wanted, but I'm not going to, and I'll tell you why. I want to add these two fractions, and when you add fractions, you have to have a common denominator, and they already do. So if I would have simplified this to a 2, there would have been nothing wrong with that. But it's just easier to leave it 8/4 because it already has a common denominator instead of me having to find it later. So what this becomes on the top is 10 root 3 plus 8 on the top over 4, because remember we carry over that lazy denominator. Now, there's a couple things I need to do here. First things first, I know that my root needs to come last. So I should actually rewrite this 8 plus 10 root 3 over 4, because that's technically the proper way to do it. I also recognize that each of these is divisible by a 2. And since each of them is divisible by a 2, I actually can go ahead and divide that out. So it becomes 4 plus 5 root 3 all divided by 2. Now let me point out, I'm going to go back over here. I was only able to divide by a 2 because both the 8 and the 10 were divisible by 2. If only one of them was divisible by 2 and not the third one, it wouldn't have worked. You can only divide by that 2 if both pieces in the top are divisible by that 2, and it was. Leaving this as my final answer.